Hi, I'm Keon, and today I want to show you how to find if a series as convergent or divergent. So you have this series, but we don't know the formula. The terms are 1/3 minus 1/6 plus 1/11 minus 1/18 plus 1/27. So we can have clearly that one part of the series, because 1 is common, we can write it as -1 to the n minus 1 power. And then you can see that in the denominator, 3 is the same as 1 squared plus 2. This is 2 squared plus 2, and so on, so on. So we can write it as -1 to the power of n minus 1 over n squared plus 2. And now, because it's an alternating series test, I want to use the alternating series test method for finding if it converges or diverges. So this whole thing is equal to an, and now I want to choose a known value. For now, I want to choose 1/n squared plus 2. So my known value is 1/n squared plus 2, and I take the limit as n approaches infinity. This is equal to bn. If I take the limit of bn, it's clearly 0. It converges with 0. So I can form this equation using the inequality using the alternating series test, that if it works, we can conclude that it converges. So b sub n plus 1 is less than or equal to bn. And now in this case, using the bn, so we get 1 over n plus 1 squared, and then plus 2. This is less than or equal to the original, 1/n squared plus 2. And this is clearly true, but for just to be clear, cross multiply, n squared plus 2 is less than or equal to. If we expand that, we get n squared plus 2n, and plus 1 and 1, we get 3. This is clearly true. If you want to even simplify it, this and this cancels, we bring this, we get -1 is less than or equal to 2n for every n value greater than or equal to 1, which means this is true. So we can conclude that the sum from n equals 1 to infinity of -1 to the power of n minus 1 over n squared plus 2 converges by the alternating series test. Thanks for watching. Please subscribe to my channel and watch previous videos.